In this video, we'll look at graph shifting and function ranges for some absolute value functions. Our question is two parts. First, we'll describe some absolute value functions as shifts of the basic absolute value function and give the range of our functions. And then, given some criteria, we'll give the symbolic form and range of some absolute value functions. For the first one, y equals the absolute value of x plus 3 and then minus 4, we'll start by creating a t-table. We'll notice that when x is negative 3, that's our smallest y value, y equals negative 4. And then there are symmetrical increases on either side of x equals negative 3. So we see here that negative 3, negative 4 is our vertex, which is 3 left and 4 down from 0, 0. When we look at the graph of that function, and we graph it, we can graph it by hand or with technology, we see our vertex there, and we see our shift of left 3 and down 4. And then we can also see our range must be y is greater than or equal to negative 4. For our second one, y equals the absolute value of x minus 2 and then plus 5. We make our t-table and we see that the change occurs when x is 2 and then the y value of 5 is the smallest, with symmetrical increases on either side of x equals 2. So 2, 5 is our vertex, which is 2 right and 5 up from 0, 0. When we graph that and compare to our t-table, we can see all that going on. And so we can see then that our range is y is greater than or equal to 5. For our third given function, y equals negative 2 times the absolute value of x plus 1 and then plus 3, we create our t-table and we see that that negative 2 flips our graph upside down, and that at x equals negative 1, that's where things bend and change, with symmetrical decreases on either side of x equals negative 1. So we see that our vertex here is negative 1, 3, which is 1 left and 3 up from 0, 0. And when we graph this and we plot our coordinate points, we'll see that this graph is the graph of y equals the absolute value of x flipped upside down and then shifted left 1 and up 3. And so our range here is going to be y is less than or equal to 3. Because everything goes down from the vertex instead of up. Now for part 2a, a function that is the graph of y equals the absolute value of x shifted right 5 and then up 7. When we looked at part b, we see that shift right corresponds to having y equals x minus h, where h is positive on the inside of the absolute value. And shift up corresponds to the plus k on the outside, where the k is positive. So if we combine those ideas, we have y equals the absolute value of x minus 5 plus 7 on the outside. Notice that if the plus sign is already there, say for example you are using a homework system, you might write that x minus 5 as x plus a negative 5. And since the graph is opening up, the range must be y is greater than or equal to 7. For part B, we want the graph to be shifted left 6 and down 4. When we looked at part A, we see that shift left corresponds to x plus h, where h is positive on the inside of the absolute value, and shift down is when y equals the absolute value of x minus k, where that k is positive on the outside. So altogether we have y equals x plus 6 minus 4. Since the graph is opening up, the range has to be y is greater than or equal to -4. So let's check this. If we graph our two functions together, y equals the absolute value of x plus 3 minus 4, along with just y equals the absolute value of x, we can see that shift left and down 4 units more readily. That's a good way to check. And we can see our vertex compared to the point 0, 0. And we can also graphically see our range. When we graph y equals the absolute value of x minus 2 plus 5 along with the absolute value of x, we can see that we're shifted right and up, and we can see our range here on our function. And then for our more complicated function, y equals -2 times the absolute value of x plus 1 plus 3, when we graph that, we can see that it's flipped upside down compared to the regular y equals the absolute value of x graph. The lines progress at a steeper slope. That's from the 2. And then we can see our shift left and up 3. And we can check each piece of this and see our y is less than or equal to 3 range. And then for part 2, we can also graph our new symbolic forms and compare them to the absolute value of y equals the absolute value of x. So you can see our shift to the right 5 and up 7, and left 6 and down 4. And we can also see our ranges there. So our answers are all together as we've already reviewed. Y equals the absolute value of x plus 3 minus 4 is y equals the absolute value of x shifted left 3 and down 4. And that range is y is greater than or equal to -4. For part B, 1b, y equals the absolute value of x minus 2 plus 5 on the outside. We're shifted right 2 and up 5, and the range is y is greater than or equal to 5. And for part 1c, -2 times the absolute value of x plus 1 plus 3, the graph is flipped upside down and then shifted left 1 and up 3. And so the range is y is less than or equal to 3. And then for part 2, we needed to give the symbolic form. So y equals the absolute value of x minus 5 plus 7 is the graph of y equals the absolute value of x shifted right 5 and down 7, up 7. That's actually supposed to be up 7. This should be up. And then y equals the absolute value of x plus 6 minus 4 is shifted left 6 and down 4 because this is the opposite. And the range is y is greater than or equal to 4.